This is an overview of how to conduct hypothesis tests in R. As a first scenario, a real estate agent claims the average home in the area contains over 2,500 square feet. Using the sample of 270 real estate listings, test whether the claim regarding square footage is plausible at a 95% level of confidence. You see in the problem description that 270 real estate listings are mentioned. And here on the right-hand side of the screen, you see a snippet view of some of those in the sample and the square footage data recorded for some of those real estate listings, just to give you an idea of what the raw data looks like for this particular test. Reading through the scenario once more, we see that the real estate agent's claim is that the average square footage is over 2,500 square feet. We'll place that in the alternative hypothesis by mu, or average greater than 2,500. By default, we will state for the null hypothesis that mu equals 2,500. Next, we'll want to translate this information to coding in R, which will look like this that you see at the top of the screen. Notice we have our hypothesis statement given once more for reference as we look through the function below, t-test, with the variable name as the first argument, the average of interest for this particular test given, mu equal 2,500. The third argument being what is the alternative hypothesis, and in this case, we are testing greater than. And finally, our confidence level is 95% expressed in decimal form. Below, you see the results of running this test. Of particular interest is the p-value. This notation here indicates scientific notation times 10 to the negative 15th. So that is effectively a decimal with many zeros, then a 2658. Just as an illustration, it would start with many zeros, and then later you would see those digits as expressed there. So that is clearly less than 0.05. And the alpha level for a hypothesis test may be determined by 1 minus the confidence level. So 1 minus 0.95 is how we arrive at that alpha 0.05. If the p-value is less than alpha, then that indicates that we should reject the null hypothesis. Since we have rejected the null hypothesis in this case, then we are finding that the alternative hypothesis is plausible. In other words, the average square footage for homes in the area is greater than 2,500 square feet. And so the real estate agent's claim was supported by the results of this test. We found sufficient evidence to support the claim that average square footage of homes in the area is greater than 2,500 square feet. Let's take a look at another scenario where the claim has changed and the framework of our alternative hypothesis and R code will also change. Notice in this description, the real estate agent has claimed homes are less than 3,000 square feet on average. Everything else remains consistent. So we will update our alternative hypothesis to express mu less than 3,000. And our null hypothesis will be updated to mu equal 3,000. To code this in R, we will want to update some of the arguments in the function. Notice in our t-test function here, we have updated the average of interest, mu equals 3,000, and the alternative test now involves a less than expression. The results below indicate a p-value of 0.759, roughly, which is not less than 0.05, it is greater than 0.05. And when that is the case, we would fail to reject or do not reject the null hypothesis. So effectively, we have not found evidence to reject this notion, so it is plausible that mu is roughly 3,000 square feet. Notice on the bottom of the screen, it actually gives you the average of the sample. We have 3,046 square feet approximately. And so 3,000 is in the neighborhood of the sample average. So it is likely that the population average may be around 3,000. Is one way of taking away some insight from this particular example. Now, related back to the real estate agent's claim that houses are less than 3,000 square feet on average, we did not find evidence to support the real estate agent's claim in this particular scenario. Let's take a look at one more. In this instance, the real estate agent has claimed that homes in the area contain 2,900 square feet on average. So to refute that, we would want to express an alternative hypothesis that homes do not have, or mu is not equal to 2,900 square feet. Update our null hypothesis to state mu equals 2,900. And for our coding in R, we will want to update or express our second argument, mu equals 2,900. Also, our alternative hypothesis in this case is what is known as a two-sided test, not equal to. Notice in the results below that we have a p-value of 0.02, which is less than 0.05. Therefore, we will reject the null hypothesis. Note R automatically adjusts the p-value shown related to one-sided versus two-sided tests. You may see in some readings that it mentions using alpha over 2. In some instances where a two-sided test is involved, R has already made that adjustment for you. Now, since we have rejected the null hypothesis, that indicates we have sufficient evidence to say that the alternative is more plausible, that the average size of homes in the area is not equal to 2,900 square feet. So we have found evidence against the real estate agent's claims that they are about 2,900 square feet.